Hi there, grade 9s. Welcome to lesson 5 of chapter 5. In this lesson, we're going to be talking about multiplying and dividing polynomials by a constant. So I'm going to go through some examples first, and we'll start with this. So here's a bunch of examples that we're actually going to kind of simplify. So here we've got a constant by a monomial, constant by a binomial, constant by a trinomial. And so we're multiplying with each of these. So feel free to pause the video, try these out, and then I'm just going to go through some of them, not all of them, because I don't want to have this video last too long. So for the first one, basically what's going on is this 2 gets multiplied to what's in the brackets. We can't really create more x's. Well, we are essentially, but what we're doing is we're multiplying it by the numerical coefficient. So we have 2 times 3 becomes 6, so we end up getting 6x. In this one down here, we have negative. So 2 times negative 3 is negative 6x. Okay, so the difference is just the negative that goes along with it. I'll do this one here. So we have 3 times 2x plus 1. This 3 technically gets multiplied into both of these numbers. So we have to go 3 times 2, 3 times 1. So 3 times 2 is going to give us 6x. 3 times 1 is going to give us plus 3. So the opposite down here would be, oh, this is supposed to be a negative. So we'd have negative 6x minus 3. So it goes the same way. Okay, I'll do this one, and it's going to be the same, just the signs will be opposite as the one above. So we have negative 2, and this negative 2 gets multiplied into everything. So we have to make sure that we're using our proper distribution and our proper rules with integers. So 2 times 2 is 4. Negative times a positive is going to be negative. So negative 4x squared. Negative times a positive is a negative. 2 times 2 is 4, so we get 4x. Negative times a positive is a negative. Okay, 2 times 4 is 8. So up here we would have the opposite. We'd have 4x squared plus 4x plus 8. All right, so those would be how we would multiply in. When we're talking about dividing, okay, we have to look at it a little bit different because we actually want to substitute it in a way that we can actually look at it better. So if we have something like this, so 9x divided by 3, let's do 8x plus 12 divided by negative 4. Okay, so let's just do these two for now. Feel free to try them out, and they're very similar. Okay. So first thing I want to do is I actually want to rewrite it so that it looks more like a fraction. So I've got 9x divided by 3. Okay? So from this situation, I can take my numbers and I can actually divide it out. So I'm going to have 9 divided by 3 is going to be 3x. Okay? Same with this one. I'm going to have 8x plus 12 divided by negative 4. I can further distribute this and say it's the same as 8x divided by negative 4 plus 12 divided by negative 4. Okay, so this is going to give me the same thing because it's being divided on both of the numbers. I'm just breaking it up a little bit. So when I end up doing it, I get negative 2x minus 3 becomes my answer. Okay, so when I divide with both of them. Okay, so now that we're talking about multiplication and division, we can talk about what the area of individual shapes might be using polynomials. All right, so I've got some examples that we might have. So let's look at something like this. So if we have 3 times negative 2m plus 4. Okay, I can try to, and m can be replaced with x or whatever we want. So let's see what it might look like. Okay, I'm going to take what is outside the bracket as my length. Okay, so I'm going to have negative 2m plus 4. So that means I'm going to have some type of a long tile as negatives. And then I'm going to have positives. So I'm going to have short tile, short tile, short tile. Okay, so this is represented as negative and negative. Okay, so then it's going to be multiplied by 3, and 3 is my constant, so it's going to go 1, 2, 3. So I'm going to complete all of these. Okay, and then these will be complete, so they'll look like this. Okay, something like this. So imagine this is a perfect rectangle. Okay, then I can try to go and actually distribute this out. So if I have my 3 times negative 2 plus 4, I'm going to go 3 times 2 is going to be negative 6m. And then 3 times 4 is going to be plus 12. So let's look at my total area. What do I have? I have 1, 2, 3, 4, 5, 6 negative 6 m's. And then, oh, sorry, I missed one row. This is supposed to be 4. Okay, and then I have 3 by 4, which is 12. So 6m plus 12 becomes my answer there. Okay, let's try another one. Let's go with here. So if we've got something like negative 2 times negative n squared plus 2n minus 1. Okay, so we'll do one more multiplication in. So for this one, you can use the distributive pattern if you want, and then we can try to figure out exactly what the answer is. So I'm going to multiply my negative 2 in. So negative 2 times negative 1 is going to be positive 2n squared. Negative 2 times positive 2 is going to be negative 4n. Negative 2 times negative 1 is going to be positive 1. So this becomes, or sorry, positive 2. So this becomes my final answer for this question. All right, let's go down and do some division examples. All right, so our first one, let's go with something like this. If we've got 4s squared minus 8 divided by 4. Okay, 4s squared divided by 8, or minus 8 divided by 4. So this one's not overly difficult. Basically what we're doing is we're going 4 divided by 4, and then 8 divided by 4. So we end up getting s squared minus 2. Okay. Let's try another one. So we've got negative 3m squared plus 15mn minus 21n squared, all divided by negative 3. Okay. So once again, this negative 3 goes into each of these numerical coefficients. It doesn't affect the variable, and it does not affect our degrees, okay, or our exponents. So 3 divided by 3, or negative 3 divided by negative 3 is going to be m squared plus 15 divided by negative 3 is going to be negative 5mn. And then negative 21 divided by negative 3 is going to be positive 7n squared. So that becomes my final answer. So hopefully that makes sense. We're going to do some more practice when we get into our Zooms. If you have any questions, feel free to contact me in Hangouts. Good luck.